Okay, it's recording now. Hopefully it will be okay. Hopefully it will save. All right. Question one is to factorize. Uh, so we get. You're struggling to see. Yo, I'm seeing it perfectly. Can everyone else not see? Maybe your screen's upside down. Maybe your screen upside down, my man. I'm not sure. Yo, I don't know what to do then, guys. For me, it's perfect by my side. But everyone else is perfect. Maybe go. Maybe wash your eyes. Something. Okay. 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 So factorizing, we get uh, a few different types of factorizing. Can anyone tell me? Okay, not here, not on this question, but what you might get confused with is grouping, and yeah, we didn't group. So what I did was, all I did was put them in a nice order. So I took this y squared minus y squared, I just put it nicely. Then this here, it will form my, it will form a actually yeah, it will form my normal quadratic equation. Yeah, the green pen you can't see nice. But this is a quadratic equation, alright? Because of that squared quadratic, yeah, quadratic equation. So that's why I have in brackets here. Yeah, it's a funny question. It's a weird question. But this 16x squared, you can do nothing with it. So don't ever try and do something with it because as you can see, we have a y squared and we have a 4y and we have a constant here. So the only thing we can do something with is is this trinomial here. That's why I put it like this into a standard equation. All right. So then I factorize it. I get y minus 2 and y minus 2. And y minus 2 and a y minus 2 is a y minus 2 squared. So then just by chance that this 16x squared and this y minus 2 squared, it forms now a difference of two squares. This
That's a beautiful question.
sorry,
Can I ask a quick question?
yeah.
How
So you see this bracket here. I don't want to factorize with a negative here in front of my y squared. I will just make my life difficult. So I take it out. And also this negative, it forms now my difference of two squares. So this is the same as saying a squared minus b squared. And a squared minus b squared is a plus b and a minus b. The exact same thing. Yeah, I have my 4x plus y minus 2 and my 4x minus y minus 2. Exact same thing. Next one. So here I can see that I have all even numbers. That usually means I can divide by an even number because all of them have an even number. So I can take out the highest common factor, which is a 2, That's why I took the 2 out there. I saw in I think in the group in the afternoon, one of the tutors they sent this question and I didn't divide first, but it's okay. It's okay. It's the same thing. But anyways, to make my life easier, I divide by 2, take out the common factor, then I write what's left. Right? If I multiply this back in, I will get the top again. It's the exact same thing. So anyways, what I do now, I sort it out. Alright? So I see here that I have a 2 square root a and I have a minus 4b. And then I see here again, I have a squared a in there somewhere. And then I see here, I have a b again. So what I did was, I sorted them out, I grouped them. Yes, grouped them. There you can see I have my like terms together, and I have my like terms together there. So I take out the common factor between my two like terms, which is my square root a, and I write what's left over. A 2 and a 3x, a positive 3x, right? Don't forget the sign in the middle. Again on this side, I take out the common factor, the highest common factor of my two like terms, then I group together, a minus 2b, and then I write what's left over. A 2 and a positive 3x. So just to check, when I multiply this minus 2b with this 2, I get minus 4b. If I multiply this minus 2b with this positive 3x, I get minus 6bx. The same thing, right? So afterwards, I must see that always when you group, you will get this. If you don't get this when you're doing grouping, you did a mistake somewhere. So this here, the same bracket. That means I have a common factor again. So I write it down and then I write what's left over, which is this and this here. Shouldn't do it like that actually. Yeah. But it is square root a and a negative 2b. Is everybody with me? Okay. Then the next one. A minus. Yeah. So always, but you can group immediately. I said it like there isn't anything wrong with it, not at all. But for me, I would make my life easier, or however you see the easy option, do it. It's the same thing. If I multiply this two in here, I will get the same answer. You will see, you will see in the questions to come, Nip, especially the manipulation of a formula. You can answer that thing in so many different ways, but it's still the same thing. And I will show you that as long as it makes sense in maths, it's fine. There isn't just one option. There isn't just one option to solve one thing. Eh? Okay. Okay, so number one, we take the. Okay, so you see for number one, we have a 16x squared, and we have a 4y and a minus y squared and a minus 4. This 16x squared, we can do nothing with it. There's nothing we can do with it. It can't do anything for us. So, because I have a y squared and and a positive 4y and a constant, I can make a quadratic equation. I can make my standard formula, and then when I put it in brackets, notice how the sign changes because I want to factorize this, and I don't want to factorize this with a negative in front of my y squared because to me, they'll make my life difficult when I'm trying to factorize. So I factorize this as a y minus 2 and a y minus 2, and then a y minus 2 and a y minus 2 is a y minus 2 squared. Then this with the 16x squared minus y minus 2 squared is difference of two squares. Let me write that. Difference of two squares. This is the exact same thing as saying a squared minus b squared. And a squared minus b squared, when I factorize it, is equal to a plus b and a minus b. The exact same thing over here. 4x plus y minus 2, 4x minus y minus 2. Okay, okay, I see. I see. I see. Let's try that. See this. Who's muted? Am I muted? No. Yeah, I can hear you. I can hear you. Yeah, you sound far away. Okay, so what you did here is what now? You said 16x squared minus 2 to the power 2 like that. Who did it like who did it like this? Okay. Y and then y minus 2 minus 4. Can you send a picture in the group, please? good question. A good question. Let us see. 4x plus 2, 4x minus 2. So you did like this. Let's just rewrite. Then you take out the 4. Okay. Okay. Minus. Then you factorize out the y. Uh, Then what do you do from here, guys? Oh, okay. So you got you, you got this as your last answer. Oh, okay. Yeah. I don't think that's correct, yeah. Yeah. Because you can't group. No, this is definitely difference of two squares. No, it is. It definitely is. This here you can't. This one here. And put it away. No, because this four is what this here. Yeah. Okay, I tell you what. Um, let me- you see, that's why minus four. You mean? Oh no. You see, you can only do that if your grouping gave you a bracket that's the same year and a bracket at the same day. Then you write what's left over. Then you can do that. You can't do that here because these are different things now. They aren't the same thing. You see? So where is that? Like over here. When we grouped here, we got the same thing. Yes, yes. So whenever you group, you must get it like this. If you don't get the same year, you did something wrong. Without a doubt, you did something wrong there. But we didn't group here on the first one though. But I tell you what, I will ask the other two to maybe they can clarify it for us. But I don't think you must worry about this for your test. I'm pretty sure. Yeah, I'm pretty sure. But I do think my one is correct. I really do because, but we can discuss it. Uh, Without a doubt, we can discuss it. Yeah, yeah, yeah. Then what do they do? If you can send us a screenshot of that question and the memo, we'll appreciate it. Because we can't be the whole night on question one, guys. We must also move. Oh, yeah, yeah, yeah. Okay, wow. Like over here, can you see on question three? Um, here we have, okay, take note now, ne? So here we have a minus 1 plus a squared 1 minus a. Why are they in the lobby? Come on, get out the lobby, guys, man. Okay, here we get. So whenever you get a question like this, you must change something. Either we change this one or we change this one. And we always change this one. We don't want a 1 minus a or a 1 minus x or a 1 minus whatever. We always say x minus something, a minus something. So I swap it and I take a negative out here to make the a positive. Take note of this now, ne? So yeah, we didn't group now, but we got the same bracket there and the same bracket here. So what I do is I write the bracket down first, or I write it down, and then I write what's left over. And we all know by now that there's a one there, even though we don't write it, there's a one there, and there's a negative a squared left over. So I write the bracket, the common factor. The common factor is a minus 1 in brackets. What's left over is a 1 minus a squared. Then again, this is a difference of two squares, so I can still expand it. This becomes 1 plus a, 1 minus a. What's my bracket there? And I can leave this as is. I don't need to change anything around or anything. This is my final answer. Simple, right? Perfect. Ha! Ha! Yeah, one thing about maths, practice as much as you can. See as much questions as possible. How much, like how they can ask it in the many different ways they can ask it. It will just give you a benefit. It will benefit you at the end of the day. The next one is complete the square. The next one is complete the square. Yo, guys, this one is normally a problem. No, you can't. You can't ask me. What you ask you? No, no. I mean, you can. You can if you want to. You can if you want to. But me, I won't do it. Me, I won't do it because you done already. You're just simplifying more. Even this will be okay. If you leave that there, that'll be okay. But yeah, at the end of the day, if you wanna change it around, it's not the same thing in maths. If you take the negative out, it's still the same thing. It's saying the same thing. So as we're only taking the negative out here, right? Because we want to get this common factor here. But besides that, we don't want to work with an awkward thing like this with an a minus one there and a one minus a there. That's why I changed it to this. But as a final answer, you can leave it as it is. Cool. Completing the square. Very important to note that if they tell you factorize this equation by completing the square, you have to complete the square using the method of completing the square. You can't do any other thing. You must do this. If you don't do this, you won't get that marks for that question. That goes for any other question you get. Goes for yes, I have to redo this. I have to redo this video of completing the square because I don't feel like I think something was wrong. I'm not sure, but I want to redo it just because for peace of mind. But anyways, let us see what we have here. Okay, completing the square. This is why you guys must go watch my videos because there's so much to note before you start, man. But okay, let's begin. So whenever we complete the square, we get our equation. We have our equation there. It's given. So the first thing we do, we get that x squared alone. That's the very first step you do. If you don't do that step, everything you do after this is incorrect. So what do? I divide with whatever is in front of this x squared. I divide with the whole equation. Everything. Divide by a, divide by a, and divide by a. That's because. So I divide by a, I divide by a there. Then my next step,
Sorry, Mr. V.
yeah,
Sorry. Before you
yes, yes. Sometimes they put the constant on the side, then you must divide also. But okay, then the next step, we take the constant to the side. You have to do that. If you don't take it over, everything you do after that is incorrect. Okay, then the next step, uh, we say in brackets, whatever, where do I write it now? Whatever this is, whatever my b value is, because as we know, this is the standard equation of uh, of a quadratic equation, all right? My standard equation, ax squared plus bx plus c. This can also be 3x squared plus 7x plus 2 is the exact same thing. My 7 is my b value. My 2 is my c value. My 3 is my a value. So, whatever your b value is, no matter what it is, if it's infinity and beyond, you write it in brackets times a half squared like this. You have to do this. You take your b value times a half in brackets squared and you add it, you plus it. You always plus it no matter what. So you say So again in the beginning, you divide by a everything to get your x squared alone. Then you take your constant over to the other side with the equal sign and you remember to change your sign. If you don't change your sign, it's all wrong. Then the next step, you take your b value, no matter what it is, you say you add it, then you say in brackets b, my b value times a half in brackets squared. Then you do the exact same thing on the other side. You add it. You add the exact same thing. Your b value times a half in brackets squared. Okay. So what you do now in this brackets here, you multiply it together. You don't put that square inside on this side of the equal sign. On the left hand side, you don't put the square in. You only multiply that off with whatever your b value is. Can be anything. So you get b over 2a, right? B over a times a half is b over 2a. Then this side, you say b times half is b over 2a, and if you square it, it's b squared over 4a squared. Makes sense, right? Here you times that square in. But this side you don't do it. You'll see now why. You'll see now why. So, so here I have a squared, and there I have a squared. So all I do is I take that x squared, and I put the x there. I take the squared falls away. It falls away. Oh, let me keep it straight. So I have a x squared. I take one x, or I don't take one x, but that squared falls away, and the x comes here. This value here, I write as is here without the squared. These two squares, they fall away and become one square in brackets here. No matter what you get, it'll be the same step. Then, whatever this sign is here, you will write it here. That sign can be anything. It can be negative, then you must put negative there. If it's positive there, it's positive there. Okay, so this is a very easy thing of completing the square. Whenever this will always be the same thing, depending on whatever variables you have, but this x squared becomes an x there. Whatever this is squared comes here as it is. So b over 2a, b over 2a. In bracket squared, both of them, right? Then this side, you must add these two together. So, yeah, hopefully you guys can add fractions, but it's very simple to add fractions. You get the denominators. Yo, can't talk, I'm sick, guys. The denominators, you must get the denominators the same to add fractions and subtract fractions. You must. That's it. Yo, can we please mute everything?
If I can bring you down in Mr. Brown.
I think so. I think so. Yeah, you spoke numbers now, but yeah, it makes sense. Yeah. So yeah, we add the fractions together. We get one big fraction. We simplify the fraction. We simplify the fraction nicely. Then what we do then is whenever you're completing the square, you want to get rid of this here of this squared in brackets. You want to get rid of it, and the only way to do that is to square root both sides. And when you square root on the right hand side, it's usually a number or a variable. But whatever it is, whenever you square root, it becomes a positive and negative, positive or negative number, whatever this is. So that means you're gonna have always two answers. Alright? So then uh what I do next is I I write I take this over now. I can take this over because it's alone now, right? The squared fold away because I square rooted. So I can take this now to this side, uh, and then yeah, this can also simplify because if you square root a fraction like this, the square root can go on top and the bottom. So when I square root of 4a squared, I get 2a. Then all I did was I added these two fractions together and it gave me this. And this is the formula that we use to factorize. I know it's a lot because of the fractions and all, guys, but the steps never change no matter what you have. Let's quickly see the next one. Yeah. Yo, this can only 4 marks, 5 marks, maybe. I don't know. Maybe. No, don't do that. Don't do that. Don't do that. What you should be doing, learn the steps. Watch that video, ne? What I sent in the group on a YouTube channel. But let me write the steps for you here. And if you apply these steps, no matter what you get for completing the square, you will get correctly. I'm sure you'll get marks. So, step one, get x squared alone. Step two, uh, constant right hand side. Step three, p value uh, times half squared. Then step four is uh, oh, that should be both sides. Because both sides, right? Don't forget both sides. Then step four is this here. Oh, how do I say this now? Okay, combine squares as is, as is. And then step five is this, or what should I say? First, simplify right hand side. Simplify right hand side. Number six is the square root now. Uh, square root, square root both sides. And then don't forget the plus or minus after your square root. Then Step 8 is to take over or get X alone. Yeah, get X alone. Get X alone. What next? Yeah, then you find. Sometimes you will do it like this, but most times you will get two values because of this plus and minus. And you'll see how now. But this is the steps you can follow. Yeah,
Hi, sorry. I just
you wanna skip it. Yeah, I say yes, skip it. If you wanna skip marks, I say you can skip the steps. No, if yeah, it's marks. But you don't wanna do the you don't wanna write these. Yeah, yeah. Yeah, letters. If you get letters, it's more work. But if it's numbers, it simplifies much better. Also, yeah, as you can see, yeah, tell me. I mean, if you complete the square, if you complete the square using your quadratic formula, you will get that formula that you use to factorize. That's why I actually did it. That's why I gave it to you. Also, just a note, guys, the meeting gonna cancel out soon. Just join again afterwards, because it's gonna cut out soon. Also, yeah, as you can see, when you get numbers, your life is much more simpler. And also, if you can do this question here, if you can do this here, that you will pass your question in the paper. Okay. So just a quick run through this because I gave all the steps. Here you get your x squared alone. You divide with 3 throughout. Then you take your constant to the side and you change the sign. Then you take your b value, whatever it is, times a half in brackets squared on both sides. Then you simplify this, you simplify, then yeah, then you write. this x squared and this 7 over 6 squared as it is in bracket squared. You take this side here, you put it there. You put it there in the middle. Then to get rid of the squared, you square root both sides. You get a plus and minus here. And lucky us, this simplifies to 5 over 6. Then, when I said you get normally two answers because of this plus and minus, you take this also over, becomes negative. Then, because it's plus and minus, I must write this equation for when 5 over 6 is positive and for when 5 over 6 is negative. That's why I get two answers. So the guy that said he's only gonna do questions that give him the most marks. Here is your marks right here. The steps never change, even if it's letters. It's the exact same steps. Okay, so now we have numbers. Let's look at the steps I gave you. So the first step, what's the first step? We get x squared alone, right? So here we have a number. To get my x squared alone, what should I do? Yes, I divide with 3 throughout my whole equation, right? Okay, we did that now. We see 7 over 3 and a 2 over 3. My x squared is now alone. It's lonely now. So my step 2 is to take my constant to the right hand side. And yeah, I did it here. Constant, right hand side. And I remember to change the sign. Okay. So my step 3, put my b value times a half in bracket squared on both sides. Yeah, I do it. My b value is 7 over 3x, but it's 7 over 3. So 7 over 3 times a half in bracket squared. I do the same on the other side. Yeah. Yo, I can't hear anything you are saying. Oh yeah, yes of course, we must add. We must add. Let's put it here. Yo, where can I put it? I put it like this. Add. Yo, I'm fighting tonight. Okay, so my next step is what? To simplify the right hand side. So this over here, I must simplify nicely. And I do that by putting in my calculator because it's numbers. So I don't just think or anything. I just put into this thing. This thing here is a calculator. So then uh, I put it in and then I get 25 over 36. So on the left hand side now, what I do here is after I put it in my bracket squared, my b value times a half in bracket squared, I take, yeah, I multiply this, right? This 7 over 3 times a half will give me 7 over 6, right? Then I take the numbers that is being squared. I take the numbers as is. The x, I put the x there. The 7 over 6, I put there. So this middle one gets ignored completely. You don't touch it, you don't think about it. All you think about is the numbers that is squared. The middle now will never be squared. Okay? Then I put them squared. So they're sharing one squared, you can say that. So to get rid of this squared now, because I want to get x alone, I square root both sides. I put a square root there and I put a square root there. Whenever you square root, a number or a variable that doesn't have a squared like this here, it becomes a positive and negative. So there's two values now. So luckily for us now, when you square root 25 over 36, you get the 5 over 6, like over here. So what do I do now? Because my x, yeah, yeah, the square over here. So let's say this. The numbers that is squared here, the x squared and the 7 over 6 squared, let's say this, that this squared and this squared, they become one. They become that squared there. Always, no matter what. So you write this number as is, you write this as is. Then whatever this sign is, you write there in the middle between them. If this was a negative, there will be a negative there. Okay? So I square rooted everything, I got plus and minus. So my next step, I take I get my x alone, and by doing that, I take this to the side, the right hand side. So I get negative 7 over 6. And because I have two values now, and I said I get positive and negative, meaning two values. So my first value would be x1. x1 equals to my negative 7 over 6 plus 5 over 6. And my x2 would be negative 7 over 6 minus 5 over 6. Then I get two answers. This one and this one here. The steps will follow through no matter what you are given. Even on the next one, on number 3, the same things were applied. I can show you quickly. I can show you quickly. So, okay, okay, let us run through this. So, my first step is to get my x squared alone. And there I did that. I divide by 2 there. I divide by 2, gives me a negative 3. I take my constant over, and the sign changes. I'll take my b value. As you can see here, my b value now is a negative. It's a negative, right? And I include that negative. So my b value times a half in bracket squared on both sides. And I also add it, right? I add it and I add it. Bracket squared both sides. Then this side gets simplified there. So my squared there, they combine and then they become one square there. I take this number, I write it as is there. I take this x and I write it as is over there. Then whatever this sign is, I write there, as you can see. Then to get rid of the squared, I square root both sides. And when I square root both sides, I get a plus and minus over here. And then lucky for us, when we simplify this here, or when we square root this fraction, I get 13 over 4 plus or minus. Plus or minus means I get two answers. That means I will get a positive 13 over 4 and a negative 13 over 4. So now that I see I get my x minus 11 over 4 alone, I get my x alone. So I take this to the other side, and the sign changes. So I have two answers. And I didn't write it down, but 11 over 4 plus 13 over 4 and 11 over 4 minus 13 over 4. And I will get answers over here. Exact same steps, hasn't changed. Um, the steps, maybe they will say, yeah, I think they will say with other calculator, but yeah, in the final steps, use a calculator, it's fine. But yeah, you can't use yeah, no, you can use calculator. They'll never say no. Uh, but these are simple fractions. These are simple fractions. So because they have the same denominator, you're just gonna add them together and say 11 plus 13, which is 24 over 4. Then I think here you'll get maybe like a negative answer. So 11 over, see, this will be 11 minus 13 is negative 2 over 4 equals to negative a half. Then, then this here will be what? Isn't that just 6? So there you have it. You have to practice also adding and subtracting your fractions, but calculate that thing one time. So, back then, when the theorem. Yeah. Uh, okay. Can you send a picture in the group? Cool. Oh, it's you. Send me a message directly. Okay. Um. Okay. The remaining factor theorem. So it's saying when fx equals to 3ax cubed plus 2x squared minus 7x plus 3 is divided by 2x plus 1, the remainder is a over 2, negative a over 2. So the first thing I do is I take this here, whatever it's divided with, I take that equal to 1 to get my x value. Yeah, I take this equal to 0. Then I just solve x really quickly. Then I take I take this x value, then I substitute it in here wherever there's an x. As you can see, there's it, and there's it, and there's it. So what this means is what the remainder means is yes, yes. So not equal each other. Yeah, they equal each other. This equation is equal to this. So that's why I wrote it like this. The equation equal to the remainder. Very straightforward. Very, very straightforward. Let's draw a nice bubble. So what do I do? I put the divided equation equal to 0. I solve x. I put this x value into my given equation equal to the remainder. Then what do I do? I manipulate, I simplify to get my a alone. Now, me personally, I don't think I can teach you how to simplify and make this nice because you can mess up so easily. All you must do is after you substitute in what you should substitute in, as it is here now, simplifying this calculator work. You get negative 1 over 8, multiply this with 3. Guys, right, donkey. Thank you. So, yeah, calculator work. Don't try and use your head or anything. You don't need to do all these steps like I did. I just did it just to show you guys. But calculator, best friend ever. When you use it, before you use it, it's on, okay. You press shift, ne? Clear. To give you these three options, you say all yes. So what I did now, I reset. You reset all the extra settings or any setting that was put in last, or maybe you press by mistake or whatever. But always make sure that you clear your calculator before any paper, because I've seen even myself calculate something, you get a different answer when you calculate it later on. And you press shift, clear, number 9. Yeah. Then 3 for all. Then yes for equal. Okay. Calculator for everything we must simplify. Okay. Yeah, I multiplied with 8 because it was just gonna make my life easier. So I multiplied with 8 across the whole equation to get this fraction away, right? So 8 times a half gave me 4. 8 times 7 over 2 gave me 28. 8 times 3 gave me 24. And 8 times a over 2 gave me 4a. Then 8 times 0 gave me 0. Then all I did, calculated this whole thing. This year, I mean, I got 56. Negative 3a plus 4a gave me a positive a, equal to 0 still. I take this, or to get a alone, I take 56 over, gave me negative 56. Straightforward. Remainder and factor theorem. Remainder and factor theorem. It's just this year. If you think about it, it's just this year. That's all it is. Yeah, I think that this is a good question. That's my writing. Yeah, yeah, yeah. Do you see my fraction as an 8? I don't want that 8 there. That 8 is making my life difficult. So to get rid of 8 being divided in my fraction, I multiply with 8 to get rid of that 8. If you didn't get rid of this 8, ne, what you would end up is with like a weird thing, man. You would end up with a weird thing where you'll have to add these two fractions together. Then you must multiply this with 4 on top and the bottom, and then you can add them. Then it's going to be the same thing. Negative 3a plus 4a over 8. Then you're going to have uh, um, a over 8 multi a over 8 equals to whatever this will equal to on this side. Then you must cross multiply. If you don't want to multiply with 8 here already, it's up to you how you simplify. Yeah, definitely. Yes, sir. Exactly. Exactly that. Yeah. Can you say it again? Yeah. 1/2 times A. Yeah. Do you do you wanna write like this? Yeah. It's the exact same thing. Yes. Yeah. Yeah. Now look, ne, you can write it in any way you feel like. As long as it makes sense in maths, you can do it. But just make sure it makes sense. Because when you mark it, it must make sense in maths. Even if you don't use my method, it must just make sense. Okay, let us move on. Determine the value of p if f of x equals to x cubed plus px minus x plus 5 is divided by x minus 2 gives a remainder of 23. So again, my first step, I take what's being divided by equal to 0. I solve my x, I get my x value. I take my x value, which is a 2. I substitute it in wherever x is. Yeah, over there's a x, there's my x, there's my x. I take my remainder equal to my equation. Then I simplify fast and in a hurry. I actually see that I changed the letter here. It should be a B. But simplify everything, and then here's my answer. Straightforward, right? Not that difficult. Okay. Okay. So long division. Um. So first, okay, first, before we get there, we read the question. The question says, prove x minus 1 is a factor of f of x equal to x cubed plus or minus 4 x squared minus 7x plus 10 and factorize completely. So this factorize completely is going to tell me what? The must divide. So my first step, I take this in brackets equal to 0. Exact same step. I solve my x, I get my x value. Yeah, radebe. Okay. So why I did this right now is because the first question, before I even divide anything, my first question is to prove that x minus 1 is a factor of my given equation. So I must take this factor because that is my factor. This is also my factor. That's also a factor. All right. But you will see now that you actually divide by your factor. But anyways, we're gonna get there. Yeah, yeah. Y- No, you see, this is the second part of the question. This is question one. This is question two. This here is question one, and this here is question two. They're two different things. And 10 times out of 1 times, whatever factor they give you, it is equal to 0. But you must do this to check. You have to. If you don't do it, you will lose your marks. Okay? Yeah? No, you must. No, you have to do that. You have to do it. Unless you can get the factor somehow. I know how, but I won't tell you so. But yeah, you don't even need to do this, but you must know it because I wanted to know it. But anyways, okay. Uh, you take this factor x equal to 1 now. You put it in. If you get 0, then you can say it's a factor. If you don't get 0, it's not a factor. Then you must state it. If you don't state it, I won't know it. Also, this. If you don't do it, I won't know it. Okay. Let us say factorize completely. So I've proven now that x minus 1 is a factor of my given equation. I must now factorize this fully or completely, like they say. So this is division. Okay. So I say x minus 1 is my factor divided by my given equation. So I say x divided by x cubed gives me x squared. Stay with me now and then. You're going to get lost. X divided by x cubed gives me x squared. Then x divided by x cubed gives me x squared. Does everybody understand why? That's nice. You guys must be must yes. You must be with me now. X3 over x equals to x squared. So anyways, I take this x squared. I multiply back now. I say x squared times x gives me x cubed. X squared times negative 1 gives me negative x squared. Then I put it in brackets and I subtract. So a positive x cubed minus, because this minus is going to multiply in also, x cubed minus x cubed is 0. Negative 4x squared plus x squared, because there's negative times in, negative 4x squared plus x squared gives me negative 3x squared. Then I bring down this negative 7x. I bring it down. I do the same thing again. I say x divided by negative 3x squared gives me negative 3x. Negative 3x times x gives me negative 3x. Negative 3x times negative 1 gives me a positive 3x. In brackets and subtract now. Again. So negative 3x squared plus 3x squared, because there's negative times in here, gives me nothing. Negative 7x minus 3x because there's negative times in here gives me negative 10x. I bring down this 10 over here now, and then I say again, x divided by negative 10x gives me negative 10. Negative 10 times x gives me negative 10x. Negative 10 times negative 1 gives me positive 10. My remainder is 0. So I write my factor that I divided with, and I write my equation here that I got now. I put it down there. Then I factorize this to get me this. Then,
Can you move your page a bit up?
oh, so yeah, this is my factor. Then I factorize these, factorize my equation to get these. Then Bob is my uncle. Then you're finished. I will try to. I will try to. But yo, the steps to just dividing now. Okay, maybe it will help you if I maybe to help myself. For now, if I just say that you don't put much mind to this. Yes, yeah, you okay? Okay, I can tell you this much. I don't think you need to worry about this question. Yo, so yeah, lovely man. So if you guys can't do it and the grade four can do it, no man, please guys, man. Maybe the grade four must do to you. Yeah, okay. Yeah, synthetic, synthetic. You can do whatever you like. This is just one method. So, yo, I don't know if I can find it anymore. But if you go to your calculator, then you say x cubed minus 4 x squared minus 7x plus 10. So we start by negative 5 and at positive 5, step in 1. Um, so I don't know if you can see here, but f of x, wherever y is 0, I believe, the corresponding x value is your factor. So here is negative 2, right? That means uh, that means x equals to negative 2. And when you take this out, when this x comes out here, so this is, so we all know that x minus 1 equal to 0, x equal to 1. Then x plus 2 equal to 0, x equal to negative 2. Then x minus 5 equal to 0, x equal to positive 5. We all know that, right? So I think, yeah. So there where f of x is 0, the corresponding x value is your factor. As you can see here, there's my x minus 2 there. So then I go more down and I see I have another one. f of x equal to 0, the corresponding value is a 1. There's my 1 over there. I go more down and I see there's a 0 again. So the corresponding x value is a 5. And then look there, there's my 5. So if I do the calculator this thing, all I must do to get back is go back. Using my brain, I go back. So you just say x minus or x plus 1. So you see, you get the x equal to 1. Then to put it in this factor form, you just take the 1 back equal to 0. Then this here is your factor. Does it make sense? Should I show you how to do it again? No, you won't lose marks. You won't lose marks. But where you gonna get your steps from? What if you attempt this, or you attempt the synthetic, how do you say it now? Synthetic. Wow, it's getting late, guys. Getting late. Synthetic division. Attempt it. If you're struggling, calculate that thing. Just put calculator. You'll get marks for the factors, but the steps, aiko, aiko daidai. So what you do is you say mode. Oh, my thing is dying now. Can everyone see the calculator? So you say mode, you say table, you get this. When you get this, you type in your equation using, I don't know if you can see that red buttons, there's red numbers or letters here. You press alpha for that. So you say whatever it is, if there's a 2 or something there in front, you put it with, but we have this now. So you say x cubed minus 4 x squared minus 7 x plus 10. When you are done with the equation, you press equal. Start. Start means where does, because this is actually a graph, right? This is a graph. My equation is a graph, right? It's a cubic graph. So this is asking me where should this graph start? And I want to start where I can get at least a few numbers in. So I'm gonna say maybe because the graph is from negative there and positive, right? I must choose a negative number. So I'm gonna say like maybe a -7, and then end at a +7. And then step means like you see when you draw a graph, then you must count all that blocks. Is it like it's almost like the scale? Is it jumping every you like is it jumping two or is it jumping one at a time? So I'm gonna say step in one because we want one. Then it'll give me all these numbers. Yo, you can't see now because my thing is dying. So you might now scroll to where you see where f of x equal to 0 because we have proven that when f of x equal to 0, it's a factor. That is why you look wherever f of x is equal to 0. I go down, there's a 0 there. So where f of x equal to 0, the corresponding x value is my factor, -2. And here I get the bottom, here my -2. I scroll more down, I see there's a 1 there for my where x equal to 0, where my y equal to 0. Uh, yeah, I hope it makes sense, guys. Uh, then I go more down, then there I see a 0 again for my y value. The corresponding x value is a 5, my factor again, and then x equal to 5. I hope everyone is winning. I don't know what you're looking at, Mr. Clyde. I can't see anything. Okay, just to check. Okay, wow. There you winning. Yeah, I can kind of see something. Steps. Yes. Yeah. Do like that. Do like that. Yes. Shall we continue? There's more. There's more. Guys, can we skip fractions? Is everybody okay with fractions? Yo, yes, tell me. Yes. No, I'm having fun. I'm having fun. I'm here because I don't want to sleep. This is, I've been telling you guys, your test is inside this papers. If you feel like you are ready, then you can go sleep. Yeah, this is test one. Yeah, the ones I sent the one I sent 2 days ago. Yeah. Yes. That's no. The numbers have changed, yes, but the steps you're using and the way the question is asked, it's inside here. Yes. Yeah, that can work also. Before we go, bef- before we go, fractions. Can we skip fractions and go straight to logs? Okay, okay. Yeah, because fractions. Okay, that can work also. Yes. Let me know when to move up. Let me see if I have something on fractions. I think if you go through, so in the YouTube net, there is a test two memo, and there is also a test one maths and three something something memo. That's 2 hours long. Then there is a test three, a test two, preparation. There should be fractions in there. So go through them. They have fractions in them. You apply the same steps. The you apply the same things over and over again. That's all maths and three is about. So if you get fractions, there's only so much fractions I can ask you. After that, it just gets repeated over and over again. Yeah, can we win? Yeah. So this now, ne, when I explain the logs, yo, it's gonna be difficult for you to understand because you don't know logs. So even if I explain to you, if you don't understand the laws, yeah, then I don't know. Let me do this. Let me. Let me do this. Let me do this before. Uh, yo, my tummy is empty, guys. My tummy is empty. I don't eat yet. Yo, log bn equals to k. B to the power of k equals to n. That's how you simplify this. Yo, okay. Number two. Maybe. I have no idea actually. This one, yes. The first one, yes. The others, I'm not sure. The others, I'm not too sure now. So this one is saying anything that has the number and the base the same is equal to 1. So if I have here log and the base is infinity and the number is infinity, it's equal to 1. If I have log 3x as the base and the number as 3x, it's equal to 1, no matter what. If these are the same, that's equal to 1. Even if he has a 2 here in front, no, I'm lying. Yeah, okay, but you will see what I mean by that. But okay, so anything that is log base 1 equal to 0. Can everyone please mute? Mute. Let's be quiet together. So anything that is log base to the number 1 is equal to 0. Even if my base is infinity and beyond, as long as there's 1 is there, it's 0, no matter what I'm given. Okay? Then number 4 is saying log base n. So sometimes my base isn't a nice number, or I want my base to get out there. So, for example, if my base is an x and I want my x out there, out from here, I can do this. I can say 1 over log nb. You'll see now how you can apply that if we're going to use it in these examples. I can do a similar thing when I say, so I can say log n over log b. Then I do this when my base and my number is they're almost similar in a way. Similar in such a way where I can choose a base for them that will simplify in a nice way. And I think we have a question like that. I'm not sure, but we can say now. You must just know when to apply and how to apply them. That's all you must know. It will make sense as we do questions on them. Next one is saying, if I have a thing that says log bn plus log bc, so the first thing you must notice when you get a thing like this, that my bases are the same. The number is different, yeah, but my base is the same. And when my base is the same with my log, And then I can write this as log b n times c. This is a rule, right? So the same or similar would be if I say this. So first thing I notice, my bases are the same. The number is different, but the base is the same. So what I do here is I say log b n over c. So the positive log goes on top, the negative log go at the bottom. The number now, right? The number. So these are my log rules. Let's see what we can do with these. Let's see.
So can we keep a page style?
No, what you can do is you can write the log laws out while you are writing. When you get to the log questions, you can write all the laws out, then you can use that page. What law is that? There actually is more. There actually is another one, but we don't really work with that. We do work with it, but we do and we don't. But it's saying ln e is equal to 1. Oh, that is ln. Ln is like log stone, brother. They work exactly the same. They work exactly the same. They get applied the same. But yeah, let us see what we can do with the calculations. Okay, so I'm given this here. I'm given this over here. Um, log 2x minus 3 log x. Now remember I said you don't want the base as x here. You want that out there. Then if we do that, then these will be the same, right? If you do that inverse of the base and the number, this will go there and this will go there. It does look like that, right? So what law will do that for me? What law will swap the base and the number for me? It's law number 4. So I do the inverse. I do the inverse of this. Now I get a fraction. But I don't want the fraction also. So what do? I multiply with the denominators. Yeah, I can't even talk. I multiply with the denominator throughout the entire equation. So log 2x multiplied with log 2x will give me log 2x in brackets squared. And then log 2x times this will leave me with negative 3. Log 2x times this will give me 2 times log 2x. There I have it. What I do now is, to make my life simple, I use the k method. I substitute my k with log 2x. So I'm going to get k squared minus 3 minus 2k. There I put k equal to log 2x. There's k squared minus 3 minus 2k. I bring the 2k over, equal to 0. I factorize this. K minus 3, k plus 1. Then I get a value for k, value for k. Then I take back now. I say k is log 2x. So log 2x equal to 3 and log 2x equal to negative 1. Here you have it over there. So then I now want to get my x alone. And the only way I can do that is if I apply the first law. So I drop the base and the number on the other side becomes the exponent and then the number goes to the other side. And there I do it. I drop the base, the 3 comes the exponent, I drop the 2, the negative 1 becomes the exponent, and then the x goes over to be alone. I simplify, I get 8, I simplify, I get a half. Now what you must know is that a log answer can never be a negative answer. So if I get a negative answer here, I must remember to say this is not the answer. Only this one is. That's just an example. I hope everyone is with me there. So yeah, this is a big question. You typically wouldn't get a question like this, but you can. Then that's the thing. You can. Whenever you get like this. So whenever you see that you can't go further than this without multiplying with log 2x throughout the whole equation. Then you see, but I have a log 2x that is squared now. And you have a 2 log 2x on this side. What do I do with it? How do you go further? The only way you can go further is if you factorize this. And to factorize this as is, you can do it when you say you can bring this 2 log 2x this side become negative 2 log 2x. But then you're working with log 2x squared minus 2 log 2x minus 3. It's a lot to keep writing and to keep track of. So the best and simplified way of factorizing like this with big things like this uh, is that using K method. This makes your life simpler. Look how simple this is. Instead of writing log 2x squared minus 2 log 2x minus 3, then I must in brackets say log 2x minus 3 brackets log 2x plus 1 brackets. It's a lot. Then log 2x equal to 3, log 2x equal to negative 1. It's a lot. It's a lot. K method is just there to make your life simple. Oh, happy chappy. So, the next one. I'm gonna do the exact same step actually. I'm gonna do the exact same thing. So as you can see, a log 2, x plus 1, log x plus 1 and 2. So what you must notice is that this is the same and that is the same. This is the same and that's the same. If I I invert them or I use the inverse on them, or if I raise them to be, I believe it's this rule here, rule 5, I can choose the base whatever I want, or I can leave it as nothing. Also, just a note that whenever you get a log question, if you get anything that is like saying, if you get anything that says, what can I say, log x, for example, the base is a 10, even if it's not written. Oh, you can't see. So if you get anything there that is log something without a base written, the base is always a 10. Even if it's not written, it's a 10. You must know it's a 10. So if I have uh, log x there and a 2, and I want to simplify that using rule 1, I'm going to write it as 10 to the power of 2 equals to x, just so you know. Uh, then learn to equals x. Then just to write something here, learn is the same. So learn, the base is e to the power of x equal to 2. Works the exact same way. That swaps there, that goes there. Just so you know. But anyways, so I'm gonna apply rule 5 here to both sides. So when I do that, the number goes on top, the base goes at the bottom, the number goes on top, the base goes at the bottom. Then I can cross multiply these. Then because this is the same as this, and this is the same as this here, it becomes squared. Then I square rooted both sides actually. I square root there and I square root there. And then, yeah. Then you know now by now that you're gonna get a plus and a minus. So then, I think this might be wrong actually. I think this might be wrong. I don't know. Let me see. Why not? Why not is this log x plus 1 log 2, and that should be x plus 1 log 2, 2x plus 1 x equals to 2 minus 1 is 1. Oh, yeah, yeah, okay, I see. No, it's the same thing. No, so they're both correct. So remember when I said log can't be 0, or log can't be negative. So this here, this answer here is negative, right? But log can't be negative. So at the end of all the calculations, you will say that not this answer, x equal to not negative half, then x will only equal to 1, as you can see here. This is a different method, a different way of calculating this. Yeah,
But it's something totally different. But
yes. See, very nice, very nice. I know this is a lot and a mouthful, but yeah. You see here, okay, because in this equation already there, I got the positive and negative, I'm gonna have two answers. That means I must do this twice times. Okay? For positive log 2 and a negative log 2. So then I set log x plus 1 equal to positive log 2. Then when you have logs equal to each other like this, you can cancel the logs and write just the number that's next to it, as you can see here. The exact same thing on this side. I say log x plus 1 equal to my negative log 2 here. Uh, then, then here, because it's a negative 1 basically, I can take this negative 1 to the positive exponent there. Oh yeah, this is one of the rules I didn't write. So when you give a log uh, like this, you can take this 2 to the front and have it as 2 times log x. But also, if you have this like this, you can rewrite this as log x squared. So you can take this and go back there depending on whatever you need at the time. So you can go back and forward like this. Yeah, no, no, because the whole log is being squared now. The whole thing is being squared. The squared isn't there. The squared is outside now. Yeah, yeah. When that's squared or but it can be anything. It can be anything. So it can also be it can be what can it be? It can be like sometimes you can have a thing like this, ne? Or no, let's do a four. Let's say it's like this. It's a four, ne? It's a four. Then this can also be written as this, right? Two and two to the power of two, ne? Then you must take this two to the front, and it's two times log two and two, ne? Then this is one of your rules. When the basis is the same as the number, it's equal to one, ne? Rule two. So then I can write this as two times one, like that. Guys, I mean, I mean, yeah, I mean, uh, I mean, I mean, technically you can, eh? Because you can do it, eh? You can even do this. Okay, log x plus 1 equal to log 2. Log 2 is actually a number. So you can put log 2 in a calculator. You can say log 2. See, it's a number, eh? Log 2 is a number. So what you can do actually is you can say 10 to the power log 2 equals to x plus 1. Then you can say 10 to the power log 2 minus 1 equals to x. Let's see what we get. 10 to the power of log 2. think we're gonna get a nice answer. But let's see. See, we get one. Oh wow. See, that's better man. You can do that also because log 2 is a number. Log 2 is actually it has a value. Sometimes to say it has a value. You can do that also, yes. See that there's many ways to get the same answer. We just did 3 ways now. Yeah. So yeah, luckily I did this now. See, I did this rule now where you break that 4 into 2 because I want to make this one. There I apply that rule. When the base and the number is the same, it becomes 1. This 2, it came to the front and was multiplied. As you can see here, it was multiplied. Here's that 2. That stayed the same. Then I take this over to the other side. Oh, and here's log b. Log b 1 gives me 0. Anything that's log to the number 1 is a 0, no matter where it's sitting. That's also anything with a base and a number the same is equal to 1, no matter what you are given and where it's sitting. So wherever your goal must be, where can I manipulate to get this 1? So you must know uh, your squares, you must know your cube roots, you must know those things because it can help you now. Okay, like if you had 8 here, then you must know I must write 2 as the base and then 2 to the power of 3. Then 3 will go to the front and multiply. So you must just know how to play around like that. But okay, and you take this negative 6 over, becomes positive 6, then you divide that 2 that's there, becomes 3. Then you can say drop the base 3 to the power of 3, x goes that side, x equal to 27. Straightforward. But also,
Okay, sorry, sir.
yeah,
It's just one question then.
yeah, yes. No, you have to. Depending on which route you're taking, you have to. Because, yes, there's a negative there and log can't be negative, but what if your x value becomes positive? That's my next question, yeah. But do everything, and then when you see it's negative here, then you just cross it out. That's just part of your steps. That's part of your steps. And okay, I mean, maybe you won't lose marks, but they want to see this one most. They want to see that one, the correct one. Because as you can see now, we did 3 methods. We did 3 methods and we got the one also. So they want the one. You must just understand. I want you to understand what you are doing. Log can't be negative. That's why we're not using it. But as part of your steps, yeah. Okay, let's see. Next one is exponents. So I have 2 to the power of x plus 5 times 2 to the power of x equal to 12. Highest common factor. I factorize out a 2 to the power of x. Can you see that? 2 to the power of x is my common factor. I put it down there. What is left over? A 1 and a 5. 1 plus a 5. Then I add it together. I divide this 6 with that 12 to give me 2. Laws of exponents says when the bases are the same, you can set the exponents equal to each other. X equal to 1. Finished. Plain and simple. Fast, quick, and in a hurry. everybody happy. Very simple and straightforward, right? Okay, next one is quite a similar of thinking. Uh, but this is just loads of exponents. So here I have a 2 and a 2 to the power of 2x plus 4. Then to write this nicely, uh, I can say, so to simplify this, I can say 2 to the power of 2x times 2 to the power of 4. Because this is one of exponents. So if you have if you have the same base, you can add the exponent. The same would be in the reverse. Because you have the same base, you can put the same base and multiply them together like this. That's those are exponents. So the exact same thing on the other side. So here I have a square root. So if I have a square root, to simplify my square root, I write x to the power a half. If I have a cube root, I write x to the power a third. If I have a square root and a square in there, I write x. Well, there's just x now, but let's put a 4 there. No, let's put a 5 there. So a square root of x to the power 5. Then I will write this as 5 over 2. This is just lots of exponents and thirds. Okay, yeah. So now I I see. So we must look now in our equation. We have 2 to the power of 2x, 2 to the power of 2x here. My equation will consist of only 2's. So I must change this 4 into a 2. So I'm going to write 2 to the power of 2x or 2 to the power 2 to 2 to the power of 2 in brackets times this. Ne? So it's become 2 to the power of 2x plus 6, technically speaking. But okay, so here's my 2 to the power of 2 ne? In brackets, my x plus 3. Then my half is coming from my third over there, my square root there. So then this square root is going to multiply with that 2. And I'll be left with 2 to the power of x plus 3. On top over here, I factorized out a 2 to the power of 2x as my highest common factor. Then I wrote what is left over. Here is my common factor, and then there is what's left over. Don't forget this negative that is there. Ne? So I simplify this, I get 8. Then, yeah, do the same thing I did here. Because it's 2 to the power of x and plus 3, lots of exponents, say I can say 2 to the power of x times 2 to the power of 3. Yeah, I do it over here. And 2 to the power of 3 is 8. So these will cancel with each other. And then the rules of exponents tell me, uh, because here I have 2 to the power of 2x and here I have 2 to the power of 1x. This 1x will cancel with this 2, with one of these 2x's that's here. And I'll be left with a 2x only. Does it make sense? Thus, we'll cancel with that one. Now, we put just a 2x. is my final answer. Yeah, a lot more. Um, Let me quickly see. Yo, let me see something. Let me quickly see. So I'm thinking now. Yo, I'm thinking now. I have to make my life a bit easier. Let me see. So here I have a log square root 1 minus x minus log x plus 1 equal to 0. Very easy. All I do is I take this log, I take it over. Then when I have logs equal to each other like this, I can cancel the logs and write just a number. This is my normal third equation. So I square this side to get rid of the square root. I square root both sides actually. You always square root both sides to take a third away from the one side. So I get this bracket here squared. I multiply out my brackets. Then I solve x like normal. Then I solve x like normal. So this x comes over, that one goes over. I'm left with x squared plus 3x. I factorize this here. I solve it for x now. So x what's left over is x plus 3. So then x equal to 0, and then x equal to negative 3. Then remember, the log can't be a negative, so x equal to 0 only. Okay, that's simple. Is everybody with me? Lovely. Um, this is exactly the same as we did now. So part of the so yeah, I have a x multiplied with a b. So when you multiply a cell and a cell together, you can write it as this together, and that's what I did over there. So you don't want a fraction, so that's why I multiplied with the denominator again, as we've been doing tonight, right? So uh, so because they're different numbers or variables, right? They could written like this. But if I have a x like that multiplied with the x like that, I will get only a x. So the square roots will cancel each other. This is things you must know. Because as you can see here, it fell away. So this square root x times that square root x will leave me with just the x over there. But here they combine. See, here they're combining now. Okay, then you're just solving x like normal. Then you square both sides to get rid of the square root. Then you solve x like normal, as we just did now. You see how the steps, they always uh, uh, repeating themselves. So then we go to something the formula really quickly. Um, like I said, you can do this many ways as long as it makes sense. It is correct. So we want n here in the exponent. So usually, if you work with letters, you use len for this formula. For the subject of the formula questions. You can use log. It is okay if you use log. I'm just saying. You can also use learn because learn is log's twin brother. Yo, who is yo that yo? You can't sleep if I can't sleep, guys. Uh, where was I? Okay, so yeah, when you have okay, I'll get to that. I will get to that. Okay, so we want n here, and n here is an exponent. Okay, so I must get learn out of there. Okay, I was doing on an extra page, but that's fine. Okay, so my job is to get in alone. Okay, that's my mission to get in alone. So I start by doing like I start by chopping the tree off somewhere, right? So I'm gonna chop here, get rid of r minus one. And to get rid of r minus one, I multiply both sides with r minus one. That is why I get the s times r minus one over here. I'm left with this now. Then I divide with a to get a away. Here I have my a. Then I have r to the power of n minus one. I'm getting closer now. Let's take this negative one, other side, plus one. This side is my third bird now. So whenever I don't want this side, I must put that side. That's how you do this. That's how you pass this question. So here I have r to the power of n, and I want n, right? So based on all all the laws and the rules that we've learned now, whose girlfriend is calling them so late? I move. Yolanda. Hey, why? Yeah. Okay. Remember? Um. Yeah. Remember I said that you can take the exponent to the front. You can take the number back to the exponent. You can do that vice versa, right? You can do that. But now, to do that, you need either a learn or a log. Remember I said learn is log stone, brother. So you can use learn or you can use log. So I know that the only way I can get an exponent to the front or out of the exponent is to use either a learn or a log. It's the only rule I know that can give me that as far as I know, right? So that is when I introduce either I can say log s r minus one like that, but I must log both sides now. You see, when you square both sides and you multiply throughout the whole equation, it's always both sides. When you introduce log or len, you must log both sides. Then what I do is this n can go to the front. N times log to the power of all power r is r minus 1, a plus 1. Then I want n alone. Remember, to get n alone is my mission. So to get n alone, I must divide with this log r over there. And I'm left with is r minus 1 over a plus 1 log r. And then there's my answer. As you can see, it is the same thing as the learn, the exact same thing because it's the same thing. Just remember, if the thing you want is in the exponent, the only way to get out the exponent is to introduce log or ln on both sides of the equation. And please don't care about how the other side is looking. It's the third one. The third one can be a mess. You must just get in alone. by any means possible. So don't worry how messy this looks or how weird or messed up it looks. Leave it as is. As long as your n is alone, you are happy chappy. Everybody okay? Everybody good with this?
Fine, but yeah, I'm good on my side.
Ah, then we must move on, boss. Okay, pick one. Which one should we do? Pick one. Okay. Yes. The moment n is alone. Yeah. The moment n is alone. Yeah. Yeah. Whatever is better for you. It's the same thing. Lovely stuff. Lovely stuff. Okay, pick one, guys. This is very easy. Let us pick number. Okay, we can do this quick, man. We can do this quickly. It's almost home time. So we want V, and V is over there. So my mission, get V alone by all means, by all means, right? So I start by multiplying with this Q to get this Q away. There's my Q this side now. T times Q. I get my P away. Divide by P. There's my P now. So I have R squared minus V squared now. So I want a positive V, so I take my V over, a V squared over. I take this fraction over. I have it like this now. Then I want my V squared without a squared. So I square root both sides. I square root that side and I square root that side. That's why I have a square root now on the side here. And then there's my answer. Fast and quick. Next one. I want T. So to get T, it's a bit of a mess. So I know I'm gonna multiply in some way. So I take the denominator, I multiply both sides with it. So I have it here now. I in brackets mr plus nt. I write m and t as it is there. I carry on there. I multiply in. Here I get imr, I get int there. I take this int to the other side because I want my t's both sides because I know I'm gonna factorize. Because imr stays there. Imr stays there. I'm gonna factorize out the t because I want t alone most. I only want t. The rest I don't want. It's gonna go in the bin other side. So I write my t. What's left over is a mn. That's mn minus in. That's in over there. So because I want my t alone, I divide with that. So it becomes that side. And the moment my t is alone, I'm finished. I'm finished and clear. So the next one is G. They want G alone now. So I start by getting G alone as much as possible. So to get alone, I divide with this 2 pi over there. So T divided by 2 pi there. Then I square both sides to get rid of the square root over there. I square both sides. There I square both sides. Uh, yeah, especially slow squared. Square root falls away. Then I actually multiplied with G to get G this side. So then here's my G that I want. Then to get G alone, I divided with this here again to put it that side. And then there's my G alone. Simple, ne? Very, very simple. as far as it's gonna go, man.
You did say you're gonna send a memo.
Yes. Yeah. This is your free marks. The last one is asking for D. So yeah, I have M equals to N times E to the power of negative BD. So I put the first thing to chop here is N. I divide with N, goes that side, dividing with N. So I have E to the power of EBD. So yeah, I used len, but you can use log also. So we're gonna log both sides because log or len is the only thing that will get the exponent that I want lowered, right? So I'm gonna log both sides now and say log m to the power or over n and log e negative bd like that. So then my log law is telling me I can take this and multiply it to the front to get negative bd log e log m over n. So remember, I want d and there is d. So to get my d alone, I must divide with minus b and net log e. So it's gonna look like this: log m over n divided by minus b log e, and then I'm finished. Simple, right? Very very simple. Okay, simultaneous equations. So I have a 2x minus 4y equal to 5, and have a y equal to 6x minus 4. All I can do is all I must see that I must do is because my y is alone, I can put this equation into here. So equation 2 into equation 1. I can do it the other way. If I simplify the first one, I can do it. It's up to me. Just got lucky that my y is alone here. If my y wasn't alone, I would try to manipulate and see how I can get either x or y alone of either the first one or the second one. So what to do? 2 into 1. So I'm going to put this one into that one. So 2x minus 4, and then this is my y value. I'm putting in that y there. 6x minus 4 equal to 5. Then I multiply in, I get 24 and 16. Then I solve x like normal. I add there, I take that side, uh, I take the negative over also, negative 22. This is a 22. What else? Yeah, then I solve x like normal. Then I get x equals to a half. So then I take this x value, then I put this x value into there to get my y value. Because remember, simultaneous, I must get the x and a y value, right? So then I do that over here, and then I get y equals to -1.
Yes.
Simple, very, very simple. Next one. Next one is saying y equals to 3x plus 1 and y equals to x squared minus 3x minus 6. So when I have a thing like, ooh, amper, okay, when I have a thing like this where I have a y there and a y there, it can be x and an x, but because my equations is both uh, alone like this, I can set them equal to each other. So I do that. This is equation 1, this is equation 2. 1 and 2 equal to each other. Then I solve x like normal. I take this 3x that side, I take this one that side. I factorize this thing, and then I get x values for this. I take this x values, I take this x value, and this x value, I put it in there. I take this one, I also put it in there. Then I get my y values. And then, yes, and then, and then I can publish my uncle. Any questions? Oh, now you stop. Yo, yo. You see, you think that, ne? But if you test yourself, I'm sure it will come back to you. I'm pretty sure. Because I'm the same way. I forget everything. But as I'm writing, it comes back slowly. But no, of course. No, of course. Anytime. Anytime. I'll be more hands on from after the test, guys. I will definitely be more hands on. So, yeah, you will hear more from me. Thank you. You too, guys. Yeah. But don't worry. We'll make a plan. We'll make a plan. Don't worry. You too. You too. Bye. See you. No problem. Bye bye.